Projectile motion is a special curve that things follow when they're moving in a particular gravitational field. So if you throw a ball, for example, anywhere on Earth, it will follow projectile motion. It's super intuitive, right?
Yeah!
If I throw a ball faster, it will land further away. If I throw it too high up, it will land right next to me.
Yeah!
But is there a way that we can use physics and maybe a little bit of maths to understand projectile motion better? And is there a little bit of help that we can get from Super Mario? This video is being done in collaboration with the weirdo Maxim, who's very kindly done all the recording of the different types of Mario motion. I appear in his most recent video, so check that out by clicking the card and say you were sent from me and say hi. Right, so projectile motion, what is it? Projectile motion occurs when you have a constant speed or velocity in one direction and a constant acceleration in the perpendicular direction to that. The most simple example is someone throwing a ball here on Earth. When the ball is launched, it keeps a constant velocity in the x direction, but because of gravity, there's a constant acceleration towards the ground. If we plot this motion on a graph, it looks a little bit like this. Another great example of projectile motion is found in video games, like Super Mario. So Maxim, are you ready?
What? No, I'm not ready. What do you think? Sticky, play the game for me.
Right, so while Maxim gets ready, I will just explain. So whether you're jumping or falling, as long as you're holding right and Y, Mario moves along the screen at a constant x velocity. But when you're jumping and falling, you are getting pulled at a constant acceleration down towards the ground.
Alright, now I'm here. Thanks, Sticky. Now, let's get into the business, Abby.
Great, thanks. So if you're just ignoring the jumps, what kind of equation can we use to describe the x motion just in the horizontal direction? If you're just holding right and there are no obstacles, you're traveling at a constant velocity v, and v equals distance over time. If Mario is passing 5 blocks every second, then in 10 seconds he's passed 50 blocks. See? Super simple. Now let's look at the y motion on its own. When Mario jumps up, he starts fast, slows to a stop at the top of his jump, and then accelerates downwards. So according to Newton, for an object with mass to slow down or change direction, there must be a force or an acceleration involved. So in the case of on Earth, or whatever planet Mario was on, which canonically is Earth, right? Because of the Mario movie, but that's not for this channel. For Earth, that force or acceleration is the force of gravity, g. Pure acceleration can be described as the change in velocity over time. So in a small increment of time, in an acceleration a, the small change in velocity is dv. So a equals dv divided by dt. So in a constant acceleration, if the speed changes from v1 to v2 in a time t, then a equals v2 minus v1 over that time. On a graph with time, the speed in a constant acceleration would make a straight line like this, and a constant acceleration in the opposite direction would look like this. In the case of Mario jumping, if up is positive, then the vertical velocity starts as a high positive number, decelerates down to 0, and then moves down into the negative numbers. So is there a way to calculate how tall Mario's jump would be if we know his starting speed? For this, we want to know the distance s in a constant acceleration. So while s equals speed times time, your speed is always changing. So the best way to work this out is on the speed time graph. Imagine a graph like this. Mario jumps up at a certain speed, v1, and slows down to v2. Distance is the speed, the upwards length, times the time, the horizontal length. Because the speed is changing though, we need to take this in small increments of time and add them up. So in the first increment, the speed is v1 and the time is a small dt. And at the next dt, v equals v1 plus a dt, and so on and so forth until we add up all of these. Adding up all these little increments in a graph is called integration, and that gives us our third equation of motion, which is s equals ut plus a half at squared. So we have all our equations of motion, and as any good physicist knows, if you have your initial conditions and a bunch of equations, then you can conquer the world, or, just work out the answer to your problem. So in the x direction, acceleration equals 0, so everything cancels out and s equals ut. And in the y direction, we have s equals v1t plus a half at squared. V at a time t is v1 plus at, and then a is a constant. And the amazing thing is, for any projectile motion, we can break it up into these components. Even if things are jumping at an angle or moving at an angle, as long as the acceleration is constant in one direction and 0 in another, then we can always break it up into their respective components. And really, these three equations of motion are all you need to get started and work out any type of projectile motion on Earth. That's the amazing thing about physics, is that 90% of it is just working out how to set up your things so that you can put equations around it. So thank you to Mario for helping me out there, and thanks again to Maxim.
Thank you very much, Steph. Hello, connectors. This is the Weirdo Maxim here. I usually make comedy skits or comedy gameplay videos in my channel. But with a collaboration with Steph, I also do a series called Expressing with Gaming, where I use a concept in gaming, in this case it would be Tetris, and see how it functions in our brain with scientific research and usually that. But also we also do interviews and such if it goes more on philosophy. If you want to check the channel and the video I collab with Steph, it should be somewhere around here, or she will put it in the description or something. Back to you.
I appeared in his most recent video, so you can check that out by clicking here. Or if you want to watch the video that the YouTube algorithm thinks you'll enjoy best, you can click down here. Alright, I thanks you all for watching, and I'll see you next time. Bye!